Hello student. So this is more mathematics and more beauty. So today we are handling the coordinate geometry, but remember to subscribe to our channel and like our videos. It will be a pretty good thing, such that we can make you a better mathematician because you're working with the very best. So we're looking at the coordinate geometry, but what does it really entail? Coordinate geometry is simply we are telling the position of someone in relation to a particular grid, unlike a Cartesian plane. So here we are simply telling the position of someone in relation to a particular plane, and at our level we can restrict ourselves to a 2D phenomenon, such that when you go to higher levels you can look at the 3D phenomenon. In other words, we are going to only deal with coordinates which are in the XY plane. You say there are coordinates which are more interesting, that are in 3 dimension, and you can use other planes other than the Cartesian plane. So if we are to restrict ourselves to that, in other words, our coordinates are always going to be in a form of x relating to y. For example, I can have a 2 something in position 2 5 in relation to such a grid 2 5. So one particular thing of interest is the gradient. If someone is located on a hill in 2D and maybe someone is standing here, how can I calculate the gradient of this person? You're there. So to calculate the gradient, I need at least 2 coordinates, one coordinate down and one coordinate up on the hill, for me to tell the gradient of the hill. The gradient is the slope. The gradient is simply the slope. The gradient is the slope or the floor of the hill. So we can now look at the gradient of the line. We can introduce ourselves into the gradient of the line. And mathematically we usually denote it by an m. How do I calculate the gradient between 2 points? Maybe I have a point A, which is 1 3, and B which is 4 7. The gradient of the line, which you can abbreviate by grad, and I call it m. So grad or m is simply the change in y. So we're saying that the gradient m is the change in y components, change in y divided by the change in x components. The change in x components, we usually denote it by y2 minus y1 divided by x2 minus x1. But even though you do the reverse of y1 minus y2 x1 minus x2, you still come up with a correct gradient. So if I use my points, I can choose any to be. So if I choose my B to be x2 y2, and then I choose my A to be y1 x1, my gradient will be, I'll have there a 7 minus 3 divided by a 4 minus 1, such that 7 minus 3 is a 4, then 4 minus 1, so this is going to be 4 thirds. So my gradient is 4 thirds, or 1.6666 recurring. So we can move to the midpoint of the line. To obtain the midpoint of the line, we only need 2 coordinates. For example, I can have P, which is -2 6, and then Q, which is -8. Can have this as -8 with a 5, such that if I'm told to find the midpoint, the formula for midpoint, I can call it capital M. Midpoint, capital M. So midpoint is a coordinate. So it is simply you get the x1 add on the x2, divide by them by 2, coordinate form y1 plus y2, divide them by a 2, such that if I'm getting the midpoint of these 2 points, I'm going to have my x1 is negative 2, so plus negative 8, that is simply minus 8 divided by 2. Then I have there a 6 plus 5 divided by a 2, such that this is negative 10 out of 2, which is negative 5, and then 6 plus this guy is 11 divided by 2, that's going to be 5.5. so 5.5, meaning the coordinates of the midpoint M is negative 5 and then 5.5. Yes, so we are again further moving to the length of a straight line. So how do you obtain length of a straight line? Length of a straight line, we simply use the Pythagoras theorem. We borrow Pythagoras from primary 7, and it is what we use to find the length of a straight line. So if I have a point maybe x, I have a point x which is 2, 5, and have another point on the end of the line. At the beginning I have 2, 5, and at the end of the line I have a point maybe 3, 4. I have a point 3, 4.